Returning to the text, one might ask, how large is large enough? That is, how large must n be for the distribution of big Y bar to be approximately normal? The answer is, it depends. The quality of the normal approximation depends on the distribution of the underlying big Y sub I that make up the average. At one extreme, if the big Y sub I are themselves normally distributed, then big Y bar is exactly normally distributed for all n. In contrast, when the underlying big Y sub I themselves have a distribution that is far from normal, then this approximation can require n equals 30 or even more. This point is illustrated in figure 2.10 for a population distribution shown in figure 2.10a that is quite different from the Bernoulli distribution. This distribution has a long right tail. It is skewed to the right. The sampling distribution of big Y bar after centering and scaling is shown in figures 2.10, figures 2.10b through d for n equals 5, 25, and 100 respectively. Although the sampling distribution is approaching the bell shape for n equals 25, the normal approximation still has noticeable imperfections. By n equals 100, however, the normal approximation is quite good. In fact, for n is greater than or equal to 0, the normal approximation to the distribution of big Y bar typically is very good for a wide variety of population distributions. The central limit theorem is a remarkable result. While the small n distributions of big Y bar in parts B and C of figures 2.9 and 2.10 are complicated and quite different from each other. The large n distributions in figure 2.9d and 2.10d are simple and amazingly have a similar shape because the distribution of big Y bar approaches the normal as n grows large. Big Y bar is said to have an asymptotic normal distribution. The convenience of the normal approximation combined with its wide applicability because of the central limit theorem makes it a key underpinning of applied econometrics. The central limit theorem is summarized in key concept 2.7. See figure 2.10. Distribution of the standardized sample average of n draws from a skewed population distribution. Figure 2.10a, n equals 1 on the horizontal axis, -3 to 3, vertical axis 0.0 to 0.5. Figure B, n equals 5. Probability on the vertical axis goes from 0.0 to 0.12. It's smaller. And C equals, figure C, n equals 25. And figure D is n equals 100, and it appears to approximate the normal distribution. That last line was reader's note.